this program, we're returning to something you've seen before. We're going to try a second version of the modelling game. You'll recall that in the first of these programs, we compared the performance of two teams in making a model of how rope shortens when you tie a knot in it. Well, when they'd finished that exercise, we gave them a tea break. And while they were at tea, we reset the studio with an important new prop. The problem this time is about bicycle lamps. You'll see that this bicycle has a lamp mounted here just by the handlebars, but it also has a socket so that we can mount it down here by the wheel. Now the problem we want the teams to decide is which of these two places is the best place to mount the lamp. Well, that's a funny sort of problem, and one of the difficulties the team will have is deciding what exactly is a bicycle lamp for. Is a bicycle lamp there to help the cyclist be seen, or is it to help him see as he travels down the road? Well, that's going to be for the teams to decide. And here's your problem specification.
Thank you.
Right, but have a look at this. In this week's programme, we're going to look at two areas of modelling that can cause problems. Deciding which problem to tackle, and keeping going with that problem. We're not looking at the details of solutions, but at the teams themselves.
Well, it fits there, all right. Shouldn't we have the positions here?
Well, there's some obvious things, aren't there, about this difference in height between those two, obviously.
There's the angle.
And the difference in angle, that seems to be pointing at a different angle to this bracket.
Well, is it that they're both pointing at some mythical point in the distance?
Somewhere down there. Yes. But, the angles certainly differ.
Well, certainly, if you have the thing up here, you can't have it pointing either straight out or to one side, or you're blinding cars coming in the other direction.
But maybe that's the idea, so that you're seen by approaching cars. Maybe that's more important than seeing where you're going.
Depends on street lighting, doesn't it?
Right, okay, so if you're driving around a street where there's a lot of street lighting, like around the city,
you don't need a light
you don't need a light at all, but you need to be seen so you don't get run over. Maybe you ought to mount it at the back, pointing backwards.
Well, there should be a backlight as well. There's a back reflector, I mean. That's the way you're seen by cars, isn't it?
So our conclusion is that you mount it at the back.
Pointing backwards.
Laughter is a sign of confidence. Both teams have just resolved the rope problem, and they're full of energy. But like you, they've got to decide what the bicycle lamp problem actually is. The first step is feature listing.
Right. First thing, what?
Well, there's the height of the light from above the ground. And there's the angle that the lamp's pointing at.
It's the standard method out of the project guide. Many features will never get into the model, but it's helping the team think. 5 minutes later, they've got to feature 15. Is there anything they've forgotten?
We want the ability, probably, to be able to switch it on or off. It's not difficult, though, is it? But to be able to switch it on and off whilst moving, because you'll be travelling in twilight, decide you need it on and not want to stop, so it's a small factor.
Yes, I'm not sure whether that comes into the actual question that we're asked.
I think we've got two problems here.
No.
We've got the first problem, where you're using your light to see your way.
Yes.
And then it's important that the light should shine on the road to a certain distance, depending on the velocity of the bike, in front of the bike.
Yes.
And the second thing is, the problem is to be seen,
Yes.
in which case you need a light which is at a higher angle, really.
It turns out that the clear statement of the two problems will help the yellow team stay focused on one particular model. They've not chosen yet, but they know that they have to. Let's leave them and look at the blue team. We join them when they've already got a feature list, and now they're examining the problem again.
Wonder what shape the beam has. It's very difficult to tell in here.
Well, we've got the black card. I guess later on we
Yes.
could try it.
It looks as if it ought to be a cone, but
Usually sort of, yes, that's right, almost parabolic, so that it comes out.
Mm.
The direction fields of Unit 2.
whether
Can
it's a,
blind you.
Yes, usually
Whether
find
it's
there's a brighter circle in the middle, don't you?
Yes, yeah, and then fuzzy around the outside. That perhaps is a nature of the middle bit.
So there's an experiment to be done. They will do it eventually, but not for another 90 minutes. They could do it now. It wouldn't take long, and it would help them choose a problem. We'll see that experiment later on. To get to their problem, the Blues next pruned their feature list.
Now, is there anything there which is totally irrelevant?
Well,
And
what-
often in a feature list there are things...
Well, I
which
think we
write down
decided
which-
to scrap the batteries versus dynamo, didn't we?
Well, yes,
down here.
that's a particular strategy that we've decided to
Yes.
adopt. So perhaps down this side, we might need to make some comments about these things so that we can see the wood for the trees or the bikes for the cars. Now in here,
It's a good start. The feature list has got them thinking, and to get to a model, they have to be fairly ruthless. The project guide has a couple of techniques you can use to help you at this stage.
we've suggested that there are two things that can be done. They can either be grouped in words, or they could be grouped in terms of a picture.
Oh, I see.
Now,
yeah. Mm.
I personally prefer the words than having to draw pictures and link them together. But the nice thing about this is that it means we can write these down anywhere on a piece of paper and link them together with lines, like roads drawn in towns. But here, we've really got to begin to get them in the right order as we write them down, although we can cross them out and improve. Which, I mean, with three of us, which we adopt. Do we adopt that one?
That's the one I'd go
Yes,
for.
yes, I
That's
think
what
so,
you'd go for
yes.
as well. Yeah.
Yes.
Well, hopefully, our grouped listing will show two problems, or perhaps more than two problems.
Yes.
I mean,
Well, there are two
one-
here, I
Yes.
think. There's
Right.
there's the environment and
Yes,
why you've got it there, the reason that you have the lamp.
to see or to be seen.
Yes, yeah.
What would you do in this situation? They've used nearly half of their allotted time, and they're still getting the problem straight. They should choose a specific problem to solve and stick with it.
And that affects the height of the lamp, and the angle. Why you want it there affects the height of it and the angle at which you want it. So that they all come together. But things like the shape of the beam, and no, perhaps not. I was going to say where the beam hits the road, the strength of the lamp. That's a feature. No.
It's natural to be hesitant, but it only takes 10 minutes to get a group feature list, and that can help. Now they've got it. They must choose their problem.
13. Right. Staggering. Well, shall we choose to do one? I think we've got three problems here. And perhaps we ought to just consider one of them.
Yeah.
This part here would be if we were designing a new lamp.
Yes.
I think that if we wanted to juggle around with some of these features, if we wanted to change the shape of the beam, if we wanted to change the strength of the lamp, if we wanted to say something about how long the battery should last, what we're doing there is trying to design a lamp for certain conditions. That's not really part of the problem that was set us. So perhaps it's one of these two that we're interested in. Now let's just remind ourselves of the question.
Yeah, good idea.
It's always worth going back. we're asked to give an account of where we should mount a cycle lamp on this bicycle. So the bicycle's not a variable. We've got one bicycle and we've got one lamp. That's the one that we have. For the sort of use we make of a bicycle, and explain briefly why your group has chosen this position.
I think we have to choose
I think
one
we
of the
do.
last two
Yes.
and work on that.
Yes. Let's...
I think I find
Let's
the last
take a-
problem more interesting, but I don't know if you
for
agree,
us
Anne.
to see.
Yes.
Well, I think if I'm riding my bicycle at night, I'm more concerned that another driver is going to see me coming than being able to see the road.
But that's because you would be cycling in a
That's
town.
because I'm cycling in a town.
Yes.
So the environment is going to matter as well, where we usually
Yes.
cycle.
Yeah.
Perhaps that's why there are two positions on the bicycle. One if we're riding in the town and one if we're riding in the country. So, yes,
Yeah.
it'd be interesting if we could actually
D-
come up with two
yes.
answers which suggest where we should put it for different cycling conditions.
That could be a red herring. They need to choose their problem and stick with it. And 1 minute later, they do.
Well,
Let's
I don't
let's
mind.
do the 2C.
The to see.
To see.
Right. So this is the one that we'll tackle.
So the blues have chosen. How about the yellows? They've not definitely chosen yet, but they're close.
That one there.
Okay, we've got to prune this list now. Obviously we can't
Street
do-
lighting or not? You think that's going to be important in
Well,
the first model?
Well,
Look at the question.
yeah,
The
depends.
question says it's for our use. I mean, it's not. So we'll take it's your use, right?
Yes.
Now,
Yes.
do you do most of your cycling in well-lit streets, or
I don't cycle very much. If I did, it would be from here to home, and it would be on cycleways, not very well lit at all.
Well, when I do cycling, it is often on street roads. So I feel 9 actually depends on which question we're asking. If we're really interested in placing the light so that we're seen,
Okay.
then street lighting is important.
Sure. So we can't neglect this at the moment. Is there anything else we can sort of neglect?
Well, number 14, the legal requirements. It'd be quite difficult actually to build that into a model at this stage.
I think that's
Okay.
something that we check at the end. So can we say forget for the time being?
okay?
So 2 features are removed. But they played their part, and it was thinking about dazzle that prompted feature 15. That's not irrelevant to a first model. More pruning, and they're ready to choose.
So, to see. Supposing we take that one first.
Okay.
So all we're interested in is seeing the
Or
road that we're about to...
would you rather look at to be seen?
No, no, that's fine.
No,
Look at
I
that
think
one
we should
first.
tackle just one problem to start off with, and we can.
Are
If
you
we've got time, we can go to the second
Happy with
one.
starting with this one?
Right.
So they've chosen, and now they can pick out the features for the first model.
This is the thing that we're asking, so
Right.
I don't have to consider that. And I think everything else probably matters, do you? In some way or other.
Well, we've got too many. We've got.
Oh, sure.
We've got. I think
now
we've
got
done
to
our light
simplify.
pruning. We've now really got to try and hack out enough so that we've got just enough left that we can model.
The most important things. Yeah.
It doesn't mean that they're committed to just this list.
Well, of course, I think...
Later on, they're adding another feature.
We want to see a certain distance ahead, because it's the to see that we're...
Depends on the
asking.
velocity, doesn't it?
Depends on the speed.
Mm.
So you've got a bike going along. I can't draw a bike. At a certain speed.
I don't think it's important to draw the right. Yes, okay.
No. Good, that's good. And
I've
you
already
want,
done the plane of the road rather than the...
you want to see a certain distance ahead,
Right.
and that distance must be such that you can stop in time not to hit the parked car here.
Okay.
So there's another thing, which is how quick... Now, this is important, 19. How quickly can you stop?
Mm.
Which is something to do with the brakes.
So, stopping distance will be important. But now it's time to start planning experiments.
Well, let's move over to the desk and see if we can understand what this light is actually doing.
Yeah.
we can try and get an understanding of what sort of shape the beam is going to be on the road.
Right.
It looks like a pretty standard sort of light. It sort of seems to be sending out some sort of cone of light, probably. Can we test that?
It's got a reflector there, hasn't it, which will shape it in some way. Yeah. Yeah. If we could have the lights down, maybe we'd see better.
That's some idea of what it's trying to do. Aha. You notice that there's sort of a central beam of light, which is quite a bit more intense than the surrounds.
Yeah.
And that beam doesn't seem to be getting large all that quickly.
No, it does change, though, doesn't it?
Yeah, oh yes.
They'll go on now to measure the spread of the beam. It's a simple, worthwhile experiment that helps the modelling. So that's the light. How about the bicycle?
So say when you're ready.
Okay. Yeah, not
Try
exactly
again.
a controlled stop.
I think your beam would better point to the right.
There's the skid.
Could you want to mark that?
No.
Do you want to try it one more time?
One more time, I think. Yeah.
Okay.
Well, they still do not have a measure of stopping distance, but they enjoyed it. The blue team tried a similar experiment.
So, if I'm a cyclist, oh, grief. I tell you, this bike would probably like a ship. It would take half a mile to stop. If I see you there, and I'm riding at 10 miles an hour, I think I'm going to run you over. So, if you could go back 10 feet, roughly twice the distance, well, I think I would feel happier at stopping
yes.
at that distance. If I was coming at you at 10 miles an hour, do you think I would stop?
I think I'd run.
You think you would run?
Well, wait a minute,
remember, with an
supposing-
extra 10 feet for me to think
That's what I
you're
was thinking,
seeing.
yes.
You know, that I'm
Yes.
seeing you there.
You see, I think if I was 3 times the 5 feet, 15 feet
Yes.
away, and you suddenly saw me, I think you could stop.
Yes.
So I think the 15's probably all right,
Right. Yes,
Okay.
that's right. because
including thinking distance.
yes, the thinking distance is perhaps quicker on a bicycle than in a car.
It's so easy to do an experiment like this. When you're clear on the problem you're solving, even something this simple can be useful. There's another experiment to be done, finding out where the beam hits the ground, and that has a surprise in it.
That lamp to me doesn't even look as if it's pointing downwards. Is it on? No, yes, it's on now.
I'll get the black board.
Well, we shan't see it. Oh, good. Are the studio lights going to go down while we have a look at this? It's way up there, look.
In fact, it's coming up here.
This is a badly designed bike.
If it is a badly designed bike, it was badly designed 90 minutes ago, when they could have done this experiment. Now they have done it. We're interested in how the team keep going. They've done some trigonometry, and they've got an angle for the top bracket, and one for the lower one.
So we now come to the problem of saying, so what? Well, let's perhaps just stand back and think.
Well, we are making one assumption, that this bike has been well designed.
Yes.
We may be right and the bike manufacturers may be wrong.
What are we aiming at in the end?
Well, what we're aiming for is to give an account of where we should mount a cycle lamp on this bicycle. Now, on this bicycle means that the top one is fixed, but the bottom one we can move up and down that
Yeah, and I think we
support.
can assume that we can change the angle as well
Yes.
by bending the bracket.
Yes. And
Now then,
where we would
see.
mount the cycle lamp for the sort of use we would make of the bicycle.
Yes,
And our simple model does tell us something.
yes,
I mean, let's think of the good points.
yes.
At the moment, it would appear that some of the numbers that we've got don't tie up very well with reality. But on the other hand, the calculation up here is for the minimum stopping distance.
Mm-hmm.
And as Mike said, you wouldn't have it such that it was the minimum. You would
No.
have it so that you could see that much
Yeah.
further. And what our simple model is suggesting is that the top bracket is fine for us wanting to see where we're going and to be able to stop. Now, in what situation would you want to be certain that we could stop? Where there are lots of people, presumably. Unless we're in the countryside and we wanted to find potholes in the road.
Mm-hmm.
Now, the second bracket suggests that if we put the bicycle lamp on there, we're going to be able to pick up people. We're going to be able to pick up people, aren't we?
Yes.
But we're not going to pick up holes in the road.
Yeah.
What we're trying to suggest here is that we're looking for holes in the road.
Mm.
But people aren't lying down. In fact, it's not zero height that we're interested in. Is it?
They do not seem to be finding it as straightforward as the ropes problem. That's because we've chosen to show you the places where the team had second thoughts. We didn't show you the mathematical modelling that produced these predictions. Now they review the worries they have about their first model.
So really, these are our worries about our assumptions. Put a nice big question mark. Now, our biggest worry is this thin pencil of
versus
light.
beam.
So we really need to investigate the thickness of the beam. I suppose it'd be the width of the beam, isn't it?
We're going to have to measure the width of that beam, which is not going to be easy. I suppose we can do it with our sheets of black paper and dark lights.
Mm.
Now, what would you do? They're close to time, and they're naturally hesitant to go round the modelling loop yet again. This could be your problem. You should leave plenty of time for reflection. But let's leave the blues and end with the yellow team. They use trigonometry as well, with angles alpha and theta, and t for the tangent of alpha. They were able to relate the height of the lamp h and the beam spread, which is given by d and l, to these angles. Simplifying gives a quadratic for t, which they solve. At the end of the day, we asked them to summarise.
Now, that's our calculation, but if we had more time, and I'd like to spend a lot more time on this problem if I could, we'd do some other things. And I think what we'd want to do is to test the lamp to see if it was strong enough. We'd like to look at the other question, that is, we'd like to be seen by motorists who are travelling towards us, and perhaps some of the discrepancy between our answers and the fittings on the bike may be because there's some compromise between the question we've answered and this other question. We'd like to take into account bends that the cycle goes around or hills that it meets, and we'd like to think a bit more about stopping distances, perhaps not taking them from the highway code for cars, but do a bit more work on some experiments there, and particularly to take account of wet roads. So I just hope we can find the odd month or so to work on this.